ports are going to be the closest port to the root bridge. Say the closest port in terms of cost path to the root bridge So closest port in terms of path cost to the root bridge. Okay. This is F0/1, F0/1. Alright. The closest port, which is, look here guys, what is the closest port to the root bridge on switch D? Is this port, correct? 0/1? That's the closest, that's directly connected to here. So the closest, once you, because this is a root bridge, these are non-root bridges. That's all it is. So the closest port to the root switch is called root port. Okay, and you must have one root port, only one root port per segment. Okay. So right now this is the root port, and this one here is a root port.
You mean by distance? And
By distance.
Physical distance?
By looking at the path cost, yes. In this case, it's 19. From that port to that switch, yeah. In this case, they're all 19. They're all the same. But in this case, that port is the closest to that root switch.
You're talking by feet?
I'm sorry?
You're talking about by feet?
No, we're talking about the bandwidth. These numbers. They're all the same, but let's say, for example, if you look at this port here of 0/2, its distance to here is 19 plus 19. Okay? Yeah. So when you look at this switch, you say, okay, port F0/1 is connected to the root switch, so it is the closest, so it's 19. And F0/1 here is connected to directly, so its cost is 19. Once you have one port as root port, and one port is only one root port per switch. Okay? So remember that, one root port per switch. So the next thing is electing designated port. Are you guys still there, or did you fall asleep? No. We're almost there, we're almost there. So when you say one root port per switch, and I already assigned it, the other ports cannot be roots anymore. The other ports have to be something else. The two things that the other ports can be either designated port, which means forwarding data, or blocking ports, blocking data. That's the only two other options you have, okay? All root bridge ports are designated, all root bridge ports are designated ports. So, all the ports in here, because this is the root, this is the root bridge. So all these ports are called what? Designated ports. All of them are forwarding. So they're all forwarding, okay? In here, we elected a root port and a root port. So the other port, this one, F0/2, and F0/2 in here, can be of two things. It can either be designated port, or it can be a blocking port. Okay? Designated port means just a port that data can go through. A blocking port is a port that blocks. So between these two, how are we going to choose which one is the one that forward, which one is the one that blocks? Okay. The thing is that this is equal. So this port says that if I want to go to this switch, it's going to cost me 19 plus 19, which is what? 38. This switch says if I want to go to here, it's going to cost me 19 plus 19, okay, which is 38. So they both have the same equal path. If they didn't have the same equal path, the one with the lowest will be forwarding, designated, and one with the highest will be blocking. But because they are equal, then there has to be a tiebreaker. Because right now they're tied in everything. So the tiebreaker in here is going to be the MAC address. Because that's the only way I can you know, get it all to work. So which one with the MAC address? This one is going to say my MAC address is all B's. This one is going to say my MAC address is all C's. When they compare each other, which one has a lower MAC address? B. So then this one is going to be designated. Okay. If this is designated, the other end can either be root. It cannot be root because the root is this port. So the only other option is blocking.